After completing this lesson, you will be able to differentiate between base, instruct, and chat models, understand model naming conventions on Hugging Face, choose the right model variant for your project, navigate Hugging Face to find suitable models, understand GGUF, quantized, and multimodal variants. When you browse Hugging Face, you'll notice the same model, e.g., Llama 3118B, has multiple variants. Let's understand what each means. What they are. The base model, which is just a model after the pre-training phase is done. So no instruction following or chat can be done with these models, and they require some fine-tuning for downstream usage. Characteristics. Completed pre-training only. No instruction following ability, no chat capability. Only does text completion, next token prediction. Example names. MetaLlama, Llama 3.18b. Note, no instruct. Unsloth, Llama 3.8b BNB 4-bit. Quantized base. Google Gemma 2 2b-ite. Wait, it, instruct. Use cases. When to use base models. 1. Continue pre-training, adding domain knowledge with unstructured text. 2. Custom chat template. You want complete control over formatting. 3. Completion tasks. Code completion, text generation, not Q&A. 4. Large dataset. You have 10,000 plus examples to teach instruction following. In my ASCII art generation chatbot, I just use the base model. Advantages? No existing biases from instruction tuning. Full control over behavior and formatting. Good for creative, regenerative tasks. Disadvantages? Requires more training data, thousands of examples, must teach instruction following from scratch. More work to get useful outputs. What they are. The supervised variant, supervised fine-tuned, chat or instruct variant is offered. This one is capable of doing chat, for example, without doing any fine-tuning at all. Characteristics. Pre-training plus. Supervised fine-tuning completed. Can follow instructions. Can answer questions. Ready for chat without any training. Example names. MetaLlama, Llama 3.18b instruct. Unsloth, Llama 3.8b instruct. BNB 4-bit. Google, Gemma 2.2b it chunks instruct. Mistral I, Mistral 7b instruct v03 use cases. When to use instruct models. 1. Small dataset. You have 1,000 examples. 2. Specialized behavior. Teaching specific personality, domain, or format. 3. Leverage existing training. Build on Meta, Google's instruction tuning. 4. Fast iteration. Want results quickly. The instruction or chat variant is very useful if you want to leverage the supervised fine-tuning that's already being done. So it also works if you don't have a lot of data. Advantages? Works with small datasets, 100, 1,000 examples, already knows how to follow instructions. Faster training, fewer epochs needed. Better starting point for most tasks. Disadvantages? Must use their chat template format, may have behaviors you don't want, safety refusals, verbosity, less flexibility than base models. Important constraint? However, you will need to make sure that you format your data in the same format that was used when actually the supervised fine-tuning is done, so you can't come up with your own chat template. Every instruct model uses a chat template to format conversations. Llama 3.1 template. Good news, Unsloth handles this automatically. There is almost no standardization in model names. Let's decode common naming patterns. Examples. MetaLlama, Llama 3.18b, base model. MetaLlama, Llama 3.18b instruct. Instruct model. MetaLlama, Llama 3.3, 70b instruct. Larger instruct model. Examples. Google, Gemma 2, 2b. Base model. 2b, small. Google, Gemma 2, 2b it. Instruct 2b. Google, Gemma 2, 9b it. Instruct 9b. With Unsloth, they just re-upload the model, so this doesn't mean anything different. Examples: Unsloth, Llama 3, 8B, BNB 4-bit, 4-bit quantized base. Unsloth, Llama 3, 8B, Instruct, BNB 4-bit, 4-bit quantized Instruct, Unsloth, Phi 3, Mini 4K Instruct, Microsoft Phi 3 Instruct. Why Unsloth uploads? Pre-quantized models that work seamlessly with Unsloth's optimizations. What is it? These are for inference use only and are not trainable. GGUF is a format for running models efficiently with Llama CPP or Ollama. Characteristics: super-fast inference on CPU, very memory efficient, cannot be trained, not compatible with PyTorch, Unsloth. Example names: The Bloke, Llama 2 7B Chat GGUF, Bartowski, Llama 3.3 70B, Instruct GGUF, when to use. Running models locally on CPU. Deployment to edge devices, using with a Llama, LM Studio, etc. For training, don't use GGUF. BNB 4-bit, bits and bytes, can be trained, quantized low-rank adaptation. Compatible with Unsloth, best for fine-tuning GPTQ, AWQ, primarily for inference, can be trained but tricky, better for deployment. Example names: Unsloth, a Llama 3, 8B, Instruct BNB 4-bit. Use this. The Bloke, a Llama 2, 7B Chat GPTQ, for inference. What they are: these are multimodal or vision variants which can also take besides text images as input. Characteristics: accept both text and images, can describe images, answer visual questions, require different training setup. Example names: Google, Gemma 2, 9B IT, text only. Google, Shop Polygemma 3B, Mix 224, multimodal. MetaLlama, Llama 3.2, 11B, Vision. Instruct for your first project. Start with text-only models. Use an Instruct model, e.g. Unsloth, Llama 3, 8B, Instruct, BNB 4-bit. Why? 1. Works with small datasets, 100, 500 examples. 2. Already knows how to follow instructions. 3. Faster training. 4. Easier to get good results. Use a base model if you have 10,000 plus training examples. You want to do continued pre-training, domain knowledge. You need a custom chat template. You're doing creative generation, not Q&A. Example: ASCII art generator, code completion. Use a vision multimodal model if your task involves images. You need image understanding, plus text generation. You have image-text paired data. Example: medical image analysis, diagram explanation. Then text generation, for fine-tuning. Text-to-text generation, sometimes used for chat, conversational, chat models. Important for commercial use. Apache 2.0, commercial use allowed. MIT, commercial use allowed. Llama 3.1, commercial use with restrictions. CC by NC 4.0, non-commercial only. Every model has a model card with description and capabilities, training data and method, limitations, benchmark scores, usage examples. Look for base or instruct in description, training details, chat template for instruct models, license. Any model can work, but Unsloth's versions are pre-optimized. Task: fine-tune a model to be a helpful coding assistant. Dataset: 200 coding Q&A examples. Choice: Unsloth Chot, Llama 3, 8B, Instruct, BNB 4-bit. Why? Instruct model works with small dataset. 4-bit quantized, fits on 24GB GPU, already knows how to code. Just need to teach your style, domain. Task: create a medical literature model. Dataset: 50,000 medical papers, unstructured. Choice: Unsloth, Llama 3, 8B, BNB 4-bit. Base. Why? Large dataset available. Continue pre-training on medical knowledge. Can fine-tune to instruct later. Full control over format. Task: make model talk like a historical figure. Dataset: 500 conversation examples. Choice: unsloth, mistrial, 7B instruct, V0, 3 BNB. 4-bit. Why? Instruct model, small dataset. Strong base instruction following. We'll learn personality from examples. Good chat capabilities. One, what's the main difference between base and instruct models? Answer: base, only completed pre-training. Does text completion but can't follow instructions or answer questions. Instruct, completed pre-training plus supervised fine-tuning. Can follow instructions and do chat. 2, you have 150 examples to fine-tune a customer support bot. Should you use a base or instruct model? Answer: instruct model. With only 150 examples, an instruct model will work much better because it already knows how to follow instructions. A base model would need thousands of examples to learn instruction following from scratch. 3, can you train a GGUF model with unsloth? Answer: no. GGUF models are for inference only, Llama CPP or Llama. For training, use PyTorch format models, FP16 or BNB 4-bit. 4. Which model name indicates a 4-bit quantized instruct model suitable for quantized low-rank adaptation training? A. MetaLlama Llama 38B. B. Unsloth Llama 38B instruct BNB 4-bit. C. The Bloke Llama 2 7B GGUF. D. MetaLlama Llama 38B instruct. Answer: B. Unsloth Llama 38B instruct BNB 4-bit. Instruct, Mars can follow instructions. BNB 4-bit, not 4-bit quantized with bits and bytes. Quantized low-rank adaptation compatible. Unsloth. Sources pre-optimized for unsloth. Option A is base model, no instruct. C is GGUF, can't train. D is full precision, uses more memory. 5. If you want complete control over chat formatting and have 10,000 plus training examples, which should you choose? Answer: base model. With a large dataset, you can train instruction following from scratch and define your own custom chat template. Instruct models require you to use their existing chat format. For the project you've been planning, 1. What is your task? Question answering, chat assistant, code generation, creative writing, domain specific, medical, legal, etc. Other. 2. How many training examples do you have? 100, very small, 100, 1,000 small, 1,000, 10,000, medium, 10,000 plus, large. 3. Do you need a custom chat template? No, standard format is fine. Yes, I need custom formatting. 4. Based on your answers, which model type should you use? Decision tree. Do you have 1,000 examples? Plus, yes, use instruct model. Leverage existing training? Plus, no, 10,000 so on plus. Do you need custom chat template? Plus, yes, use base model, DOSUS, full control. And plus, no, use instruct model, faster training. 5. Write the exact Hugging Face model name you'll use. Example: Unsloth Llama 38B instruct BNB 4-bit. Suggested models for beginners: 7B, Unsloth Llama 38B instruct BNB 4-bit, most popular. 3B, Unsloth Gemma 2 2B8 BNB 4-bit, faster, less capable. 13B, Unsloth Llama 3.1 13B instruct BNB 4-bit if you have 24GB VRAM. 1. Base models. Such pre-training only, no instruction following. 2. Instruct chat models, such pre-training plus SFT, ready for chat. 3. Use instruct for small datasets. 1,000 examples. 4. Use base for large datasets or custom formatting, 10,000 plus examples. 5. GGUF, show inference only, don't use for training. 6. BNB 4-bit, show trainable quantization, perfect for quantized low-rank adaptation. 7. Unsloth uploads are pre-optimized and easiest to use. 8. Always check the model card for license, capabilities, and limitations. 9. Chat templates are handled automatically by the tokenizer. 10. For your first project, use Llama 38B instruct BNB 4-bit. Congratulations! You've completed Module 1's theory lessons. You now understand what fine-tuning is and when to use it, retrieval augmented generation versus fine-tuning decision framework, how LLMs are trained, pre-training, SFT, alignment, GRPO, low-rank adaptation and quantized, low-rank adaptation, memory optimization, model types and selection. Next step, test your knowledge with Module 1. Quiz after the quiz, we'll move to Module 2. Environment setup, where you'll install Unsloth on your Windows 10 system with Tesla P40 GPUs. Resources: Hugging Face Models, HTTPS, huggingface.co models. Unsloth models, HTTPS, huggingface.co unsloth. Model cards. Examples, HTTPS, huggingface.co docs, hub model cards.